Hello students, in the previous session we have started with the topic of error analysis and we have discussed types of errors and then we have discussed how to calculate certain errors like absolute error, mean absolute error, relative error and percentage error. Now we need to discuss how the errors are propagated, means how the errors are combined when the result involves the addition, subtraction, multiplication or quotient of two measured quantities. So we will start with systematically, start from one topic to another, right? So let me give you a simple example first. Suppose we make use of a ruler, a scale, and the measurement of a thread by using a meter scale is found to be, say, 27.8 centimeter. Say it is 27.8 centimeter. Now look, a scale has got 10 equal divisions. It's like this. The 0 and it has got 10 equal divisions. 3, 4, 5, 6, 7, 8, 9, 10. So this is the minimum measurement which an instrument can measure most accurately. And it is equivalent to this one. It is equivalent to 0.1 centimeter or it is equal to 1 millimeter. Student, this minimum measurement which an instrument can measure most accurately is known as its least count. Right? So this instrument can be helpful in measuring the length up to one place of decimal correctly. Up to one place of decimal. So actually, considering this limitation of this particular instrument, this observed value is to be written like this: 27.8 plus minus 0.1. This is in centimeter, so it needs to be also taken in centimeter. It should be in centimeter. This is the correct way of writing the observed value. What it suggests is the range of this value would be from 27.8 minus 0.1 to 27.8 plus 0.1, which is 27.7 to 27.9. This is the range where the observed value of the length can lie. Clear? So this is the correct way of representing the measured value of any physical quantity. This will be the true value and this is actually the absolute error. So any physical quantity, suppose it is x, in terms of absolute error, it will be represented like this: x plus minus del x. If it is a, then it is expressed as a plus minus del a. This is the true value and this is the absolute error. In case it is m, then in terms of absolute error, appropriate way of representing it is like this: m plus minus del m. So this represents its true value, this will represent its absolute error, right? So let's start with the very first topic. There are 5-6 articles based on the propagation of errors. We'll start with the simplest one. We'll start with the addition case. That is, let's discuss the first case. When the result involves addition of two observed values. Two observed values. Suppose the result is x and the two observed values are a and b. So we are dealing with this case. Let x is equal to a plus b. This is the result and a and b are the two observed values. So how the errors are propagated when the two observed values includes the addition between them. So that is what our intention is, right? So again I repeat, we are dealing with the first case and we are dealing with the topic of propagation of the combination of errors. So first case is that of addition, when the result involves the addition of two measured quantities. Now students, I have told you how to express the measured value, how to express the result in terms of the absolute errors. Suppose del x, del a and del b be the absolute errors, in the measurement of x, a and b respectively. Then obviously we can write equation 1 in terms of their absolute errors. X in terms of their absolute error may be represented as x plus minus del x, right? A in terms of absolute error may be represented as a plus minus del a, and b in terms of its absolute error may be represented by b plus minus del b. So if you rearrange the terms, what you get is a plus b plus minus del a plus minus del b. Now look, x plus minus del x is equal to, what is a plus b from 1? It is x plus minus del a plus minus del b. X and x will cancel, will be left with plus minus del x is equal to plus minus del a plus minus del b. So basically there are 4 possibilities on right hand side: plus del a plus del b, plus del a minus del b, minus del a plus del b, and minus del a minus del b. Now which one is to be considered? Now students, look, while dealing with errors, we always consider the maximum permissible error. In any measurement we say maximum error can be this much. So that provides us a limit. Okay, beyond that limit, the error cannot take place, right? So while dealing with errors, we always consider maximum permissible error. That is the most logical thing. In case we consider minimum permissible error, then what it would suggest is that this is the minimum error and maximum error can extend to anything. So that will be in a sense a vague. So while dealing with errors, we need to always consider maximum permissible error. Whether we are dealing with the addition of 2 measured quantities, subtraction, multiplication, division, wherever. Whenever we deal with error, we need to always consider maximum permissible error. So that will give us the correct range of the measurement of that particular physical quantity, right? So, taking maximum permissible error, what we get is del x, it will be equal to del a plus del b. So this is the result. So whenever the result involves the addition of 2 measured quantities, then the maximum absolute error in x is given by the sum of the maximum absolute errors in a and b. This is the maximum absolute error in x. It is maximum absolute error in a, and del b is the maximum absolute error in b. So this is the conclusion. So students, wherever you deal with a physical quantity which is given by the addition of other 2 observed values, then while dealing with errors, you always consider this particular result. So again I repeat the conclusion. Whenever the result involves the addition of 2 measured quantities, then the absolute error in the result is given by the sum of the maximum absolute errors in a and b, right? Let's consider an example. Suppose it is a thread or a wire whose length is measured to be, say 10 plus minus 0.1 centimeter. This is the second wire whose length is measured to be, suppose 8 plus minus 0.1 centimeter, right? What will be the total length of the 2 wires when they are joined together? So that would be definitely given by L is equal to L1 plus L2, isn't it? If you wish to find out the total length of the 2 wires when they are joined together, then the total length would definitely be given by addition of these 2. So this corresponds to this particular case. when the result involves the addition of two measured quantities. Here L1 and L2 are the two measured quantities. So we will discuss it, or rather we will divide it into two parts. True value and then error. So this is the true value basically. And how to deal with the error? This is the result. This is how the errors are propagated in case of addition. So here what should we write is del L, it should be equal to del L1 plus del L2. This will give us the true value and that will give us the absolute error in the result. This is how addition is propagated in errors. So let's get the value. L1, true value of L1 is 10. True value of L2 is 8 in centimeters. So that will give us 18 centimeters. Clear? What about del L? This is the absolute error in measurement of L1, that is 0.1. This is the absolute error in the measurement of L2, that is again 0.1. So it will give us 0.2. So the result would be, in terms of absolute error, it will be L, that is 18, plus minus del L, that is 0.2. And it will be in centimeter. Clear? This is the correct way of writing the result in terms of absolute error. This is L, the true value, and this is the absolute error, that is del L. Now, if we wish to write this result in terms of percentage error, so what would be the percentage error? Percentage error would be del L divided by L multiplied by 100. So what do you get? What is del L over here? It is 0.2. What is L over here? It is 18 multiplied by 100. So suppose it is X. So how do you write the result in terms of percentage error? That will be written as 18 plus minus X percent. This is how the result is written in percentage error. I hope it's clear. So case 1 is when the result involves the addition of two measured quantities. Right? So in the second case, we will discuss when the result involves the subtraction of two measured quantities. When the result involves the subtraction of two measured quantities. Let's see in that case how the result gets propagated. Right? So when the result involves subtraction of two measured values, that is what we are supposed to do. Okay, what to do is, this is case 2. When the result involves the subtraction of two measured quantities. When the result involves subtraction of the difference, subtraction of two observed values or measured values. Here again let X be the result and A and B be the measured or observed values. So we are dealing with this particular case when the result involves the subtraction or the difference between the two measured values, right? So again we will consider the same thing. Let del X, del A, del B be the absolute errors in the measurement of X, A and B respectively, right? So we can write X in terms of absolute error like this. We can write A in terms of absolute error like this, A plus minus del A. Over here we are dealing with subtraction, so it will be minus, and then B in terms of absolute errors, it can be written as B plus minus del B. It can be written as B plus minus del B. So now let's evaluate it. Let's keep on solving it. What do we get is X plus minus del X. It will be equal to A plus minus del A. On opening the bracket we get minus B. Over here it will be minus plus del B. So rearrange the terms. A minus B plus minus del A minus plus del B. This is X, isn't it? A minus B is equal to X. So these two get cancelled out. So what is left with us is plus minus del X. It will be equal to plus minus del A minus plus del B. Clear, students? Again, right hand side has four possibilities. Plus del A plus del B, plus del A minus del B, minus del A minus del B, minus del A plus del B. These are the four possibilities. But which one is to be considered while considering errors? Always we need to consider maximum permissible error. maximum permissible error. So considering maximum permissible error, we get del x is equal to del a plus del b. This is the maximum permissible error. So this is the result. So students, consider the first article and this article. Whether the result involves addition of two measured quantities or it involves the difference of two measured quantities, the errors are propagated in the same manner. That is, in this case also, the maximum absolute error in the result is given by the addition of the maximum absolute errors in A and B. So the conclusion obtained in both the articles is same. So whether the result involves the addition of two measured quantities or it involves the difference of two measured quantities, the errors are propagated in the same manner. The maximum absolute error in the result X is given by the sum of the maximum absolute errors in A and B. Right? So, before we proceed with the third article, let's deal with a question related to this. Suppose, again, this is a wire, a metallic wire. Its length is given to be 10 plus minus 0.1 centimeter, right? And it is supposed that temperature is 0 degrees Celsius. Now, as we are aware, with the increase in the temperature, it will expand, being a metallic scale. So, suppose at 100 degrees Celsius, the length increases and it is represented as, suppose, 12 plus minus 0.1 centimeter. Right? We are supposed to find out the increase in the length of the wire. And we need to express the result both in terms of absolute error as well as in terms of percentage error. Let's do it. So what would be the increase in the wire? This distance. This is suppose the increase in the length of the wire. It would be equal to L2 minus L1. Right? So, as I have told you in the previous case, we will divide into two parts. First, to deal with the actual value, L would be equal to L2 minus L1. Right? So, this is related to this particular topic. That is when the result involves the difference of two measured quantities. The difference of two measured quantities. In this case, how the errors are propagated? The errors are propagated in this particular manner. The maximum absolute error in the result is given by the sum of the maximum absolute errors in L2 and the maximum absolute error in L1. Clear? So, this will be given by addition. So, while dealing with the numericals based on error analysis, please divide into two parts. Real value and the errors. Errors are propagated as per the result obtained in the articles. Right? So, what's the true value? What is L2? This is the true value of L2, that is 12. What is L1? True value of L1, it is 10. So L would be equal to 2 centimeter. Now let's find out the absolute error in this measurement, in this result, del L. It is del L2. This is L2 true value and this is del L2. This is 0.1. What is del L1? Absolute error in L1, again 0.1. So del L, it will be equal to 0.2. So how to express the result? It will be expressed as 2 plus minus 0.2 and centimeter. Is it okay, students? This is how the result can be written in terms of absolute error. So again I repeat, whether the result involves addition or subtraction, the errors are propagated in the same manner. Right? And in terms of percentage error, result in terms of percentage error, it will be 2 plus minus, what will be the percentage error? Percentage error is absolute error divided by true value multiplied by 100. What is the absolute error? 0.2. What is the true value? 2 multiplied by 100. So that will give you the percentage here. Right? So I think it will be 10%. So 2 plus minus 10%. So this is the result in terms of percentage error. I hope this sort of numerical should make every concept clear related to the propagation propagation of errors involving addition and subtraction, right? So this is how it can be easily solved. Let's proceed with the third article as well. Third article is when the result involves the product of two measured quantities. When the result involves the product of two measured quantities. So let's discuss the third one. When the result involves the product of two measured quantities. So here again we will consider x to be the result and a and b be the measured quantities. Okay. Let's start with the third case when the result involves the product of the two observed or measured values. When the result involves product of two observed values, right? So that is, we are dealing with the case where suppose x is equal to a into b, right? In the first case we have discussed the result involving the addition of two measured quantities, x equals to a plus b. In the second case we have discussed the result involving the difference of two measured quantities, that is x equals to a minus b. In this case we are dealing with the result involving the product of two measured quantities. Again, let us consider del x, del a and del b with the absolute errors in the measurement of x, a and b respectively. So, if you write equation 1 in terms of absolute errors, what you get is x in terms of absolute error may be written in this manner, a in terms of absolute error may be written in this particular manner, b in terms of absolute error may be written in this particular manner, right? Now, keep on solving it. What you get is ab plus minus, or rather what you do is, instead what we can do is take a as common. So you can write it like this, 1 plus minus del a by a. Over here you can take b as common. So it will be 1 plus minus del b by b. Right? So x plus minus del x is equal to ab. And over here 1 plus minus del a by a and 1 plus minus del b by b. Now look, what is ab? ab is equal to x. So in place of ab you can replace it by x. So it can further be rearranged in this particular manner. X plus minus del x divided by x, isn't it? So it will be 1 plus minus del a by a, 1 plus minus del b by b. Let's solve it. X by x, it will give us 1 plus minus del x by x. Now, product of these two, you can open the bracket. So what you get is 1 plus minus del a by a plus minus del b by b, and product of these two terms, plus plus is plus and minus minus is also plus. So we get del a del b divided by ab. Simply open the bracket and just solve it. So we'll get this. 1 get cancelled, right? So also remember del a, it's absolute error which is very small as compared to a. Del b, it's extremely small when compared to b. It's a small error, representing small error. So what I mean to say is that, consider this term. Numerator is the product of two extremely small quantities. Now the product of these two extremely small quantities will be still smaller, while the denominator is very large. So this entire term will approach to 0. This term can be neglected. Again I repeat, del a is very small, del b is very small, so their product del a and del b would be very small. It will be negligible. It can be logically neglected. So this term can be neglected as it will approach to 0. Therefore we are left with 1 will get cancelled. So we'll be left with plus minus del x by x is equal to plus minus del a by a plus minus del b by b. This 1 will get cancelled. Right? So students, again, in the right hand side we are getting 4 results. Plus del a by a plus del b by b, plus del a by a minus del b by b, minus del A by A plus del B by B, and the fourth one is minus del A by A minus del B by B. But as I have told you, while dealing with errors, we need to consider maximum permissible error, right? So, taking maximum permissible error, what we get is del x by x is equal to del A by A plus del B by B. So this is the result. Now look, this is maximum relative error or fractional error in x. It is maximum relative or fractional error in A, and it is maximum relative or fractional error in B. Right? So this is the conclusion. So when the result involves the product of two measured quantities, then the errors are propagated in this particular manner. That is, the maximum relative error in the result is given by the sum of the maximum relative error in the individual measurements. It can further be modified in some alternative form. Multiply throughout both the sides by 100. So what you get is del x by x multiplied by 100. It will be del A by A multiplied by 100 plus del B by B multiplied by 100. So look, this is the fractional error or relative error, and when it is multiplied by 100, that will give percentage error. So this is maximum percentage error in x. It is maximum percentage error in A, and this is maximum percentage error in B. So this is another very important conclusion, right? So students, please do remember these conclusions. Whenever the result involves the product of two measured quantities, then the errors are always propagated in that particular manner in terms of absolute error. Maximum absolute error in the result is given by sum of the maximum absolute errors in the individual measurement, right? So, again, as done earlier, let's concentrate on numerical based on this article. Suppose a rectangular field is given. Its length is measured to be 10 plus minus 0.1 meter, while the breadth is measured to be 5 plus minus 0.1 meter. Find out the area and express the result. We are supposed to find out the area of this field and express the result in terms of absolute error and percentage error. What I have told you is, we'll do it in two parts: true value and error. What is true value? True value of the area of a rectangular field, it will be length into breadth. And whenever the result involves the product of these two measured quantities, then how the errors are propagated in this particular manner. So what to do is, del A by A is equal to del L by L plus del B by B. This is what I have used. The maximum absolute error in the result is given by the addition of maximum absolute errors in length and breadth. I made use of this result which we have obtained in this particular case, right? So, true value is dealt separately, errors are propagated and they are dealt separately, right? Let's find out the true value. What is the true value of the length? 10 units. What is the true value of the breadth? 5 units. So, area would be 50 meters square. Meter, that will give us meter square. Now, in order to find del A, let's substitute the value. Del A over, what is area? True value of area is 50. What is del L? Del L is 0.1. What is L? It is 10. What is del B? It is 0.1. What is B? It is 5. So, we can solve it. Del A by 50 is equal to 1 by 100 plus 1 by 50. So, del A, it will be equal to, cross multiply it, so it will give us 50 by 100, that is 1 by 2 plus 50 by 50, that is 1. That is 1.5, that is 3 by 2 or 1.5. Therefore, how to express the area? It will be expressed as 50 plus minus